In this 3D Shoemaker video, I'm going to show you a new way to 3D print flexible orthotics on FDM 3D printers. The orientation used allows for even large sizes to be printed on average size 3D printers, and even multiple pairs may be possible. The approach relies on more intelligently designed support material than you can get from conventional slicers. 3D printing flexible orthotics and insoles, usually with TPU filament on FDM 3D printers, is becoming somewhat commonplace. The typical approach is to simply print the orthotic in a flat position, and the design is flat on the bottom such that support material isn't required. But the bottom of a shoe last is not flat. For instance, there is often some heel height, toe spring, and some roll in the ball and heel areas. This mismatch between the orthotic bottom surface and the shoe last bottom surface will affect fit, likely adversely. That is why I've tried to 3D print orthotics with support material, as I explained in a previous tutorial. But conventional support material is wasteful and a pain to remove. And if you are lucky enough to have a competent multi-material 3D printer where the part material can be TPU, my Bamboo Lab X1C falls short here, you could use a different support material, but it is still time-consuming and costly. And there are a couple other issues with 3D printing orthotics in a flat position. First, this orientation takes up a lot of space in one dimension, and thus full-length orthotics for even average-size shoes won't fit on average-size 3D printers, let alone multiple pairs. Second, layer striations are clearly visible, detracting from the aesthetics of the 3D printed orthotic. The orientation that solves these issues is where the orthotic is tilted to approximately 45 degrees. At this angle, support material for overhangs is not required. The only need for support material is to stop the part from falling over. So instead of 3D printing a whole lot of unnecessary support material, all that is needed is a smart support that taking the form of something like a skirt or a fin. And this smart support can be easily torn away after the print is done. If it is only a 3/4 length orthotic that you are 3D printing, then an average size 3D printer can fit it vertically at 90 degrees to the bed, and in this vertical orientation, multiple pairs can fit on a single print bed, allowing for batch production. At this point, you might be wondering how to go about getting orthotic 3D models with these kinds of smart supports. That's where 3D Shoemaker comes in. You can either purchase 3D models of orthotics and specify smart supports on 3dshoemaker.com, or you can design them yourself using the 3D Shoemaker plugin for Rhino. If the former, simply choose an orthotic design, and in the ordering form, make sure to specify smart supports. For a bit extra, the supports settings can be tweaked. Support thickness. This is how thick the support is. It should be at least 1 nozzle diameter thick. By default, it is 0.9 millimeters to allow for up to 0.8 millimeter nozzle diameter. Tilt angle. This is the angle the orthotic is tilted. By default, it is 90 degrees vertical for 3/4 orthotics, and for 45 degrees for full-length orthotics. Remove toe spring. By default, toe spring is not removed. This means that a general tilt of 45 degrees may still result in the toe area being at a lesser angle due to toe spring, something more like 35 degrees. Depending on your print configuration, this level of overhang may require support material. So you can either have the toe spring removed or print the entire orthotic at a steeper angle, which takes up more vertical space on the 3D printer. In my experience, printing TPU at 35 degrees does not require additional support material, so it's likely fine to go with the default for this option. If you want to design smart supports yourself in the 3D Shoemaker plugin, then this can be done via the print button on the side panel. Simply choose the angle you want, the thickness of the support, the base height, and whether you want the toe spring removed, and press the Go button. The orthotics and smart supports are generated and can then be exported to the slicer of your choice and 3D printed. Note that I recommend printing with a brim. That's all for this 3D Shoemaker tutorial. If you found it helpful, please like and subscribe to the channel. Thanks for watching.